What's up, guys? We are going to continue on our last lesson. This is all about the last step in naming. So here's where we've been. We've been writing formulas. We've been writing names. We've been doing a lot of stuff, and basically we boiled it down to two things so far. You have a single charged metal or you have a multi-charged metal. And remember, multi-charged metals always have Roman numerals and single charged metals don't. The basis for that is based on what's going on in the periodic table. Okay, single charged metals, they can only have one charge. Multi-charged metals can have multiple charges. So that's the reason why we use Roman numerals, because we need to know what charge it is. All right. The last thing we're going to do is this thing called polyatomics, okay? And it's just an addition to the single charged and multi-charged. The only thing that changes is what's on the back end. Okay, so the same rules apply for the metal, the front end, and the back end is it's going to change. Okay, so what is a polyatomic? It's a groups of atoms with positive or negative charge. Okay, when I say groups, I mean they're non-metals and they're just packages of these non-metals. Okay, and they just exist together. They're just there to for each other. They have a charge, and we will always know the charge. All right. Names and formulas are found on the back side of your periodic table. Compounds of these ions are formed the same as ionic compounds. Okay, so we use the same rules as we did before. So here's the chart. Okay, well, there's a bunch of them, but we're going to really focus. We're going to slim it down, and we're going to focus in on four of them. All right, nitrate, carbonate, sulfate, and phosphate. You've probably heard these words before, like nitrate, that's in your fertilizers, carbonate, carbonation in your pop, sulfate and phosphates. Okay, those are also in our world. A lot of them are. Okay. Now, where do I find this? It's on the back side of my periodic table. If you ever need to find it, it's right there. Okay, I just blew it up right there. So if you look here, if I just open this attachment, there it is. There's my polyatomic ions, all right? And a common thing with polyatomic ions is they have the ending 8, okay? Because a lot of people kind of go like, well, nitrogen, that's on the front side of the periodic table. That's what we call nitride when it's bonding. But all of a sudden you change the suffix to nitrate, it's actually NO3. Okay, so it's kind of a very small difference, right? Or carbonate, okay, sulfate, not sulfide, phosphate. So if you ever see those 8s at the end of that, then you can cue in that it's a polyatomic ion. Poly meaning multiple atoms. Alrighty. So what is a polyatomic ion? This is on your notes packet. So just kind of type this in as we go through it. What is a polyatomic ion? It's a group of charged nonmetals. Okay. The group of charged nonmetals. It's a package, right? You got in nitrate, you got one, okay, you have one oxygen, or 3 oxygens and 1 nitrogen. And then if you look really close, you can see the charge that says -1 up top. And this says -2. And this says 2 minus. So it applies to the whole package. All right. 3 minus. It applies to the whole package. Okay. Where can I find these lists of polyatomic ions? Well, I can find on the back side of your periodic table. Backside of the periodic table. And what are the 4 ones we're going to talk about? It's going to be this: nitrate, which is NO3, phosphate, PO4, okay, carbonate, CO3. Notice they're all capital letters, okay, that's how you can also know. And then what was the last one? Sulfate, SO4. All right, and this has a -1 charge, this has a -2 charge, this has a -3 charge, and that has a -2 charge. Okay, so that's kind of the gist of what a polyatomic is. Now we're gonna write formulas using this. All right, here's the rules. Check to see, and this is in your worksheet too. Check to see if it's a single charged or multi-charged metal. Well, how you can check is if the name has a Roman numeral in it, all right? You need to figure out the charge on the periodic table or using Roman numerals, and then we'll crisscross them just like we always did, okay? So I'll do this one right here. Magnesium is Mg, and sulfate tells me it's SO4. Okay, so I wrote it out. Now let's go to my periodic table. Let's check out what Mg is. Mg is +2. Okay, and sulfate, I just look on my backside of my periodic table, and I find that sulfate is -2 overall. Okay, so it's -2. Okay, and our crisscross rules say if these are equal, don't crisscross. So then my final answer is MgSO4. Alrighty. Go ahead, pause the video here, see if you can do zinc nitrate. Okay, so zinc nitrate, Zn, okay, and then nitrate, not nitride, is NO3. Okay, well, if I look on my periodic table, I can find out that zinc is +2 and nitrate is -1. Okay, +2 and then -1. Okay, so now the question is, what do I do? They're not equal, so I crisscross them. Crisscross. All right, and this is where it gets a little tricky. Okay, if you crisscross them, here's what you were going to get. Zn, NO3, and then 2. Well, that doesn't really look right, okay, because I don't have 32 oxygens. That'd just be weird. So what we need to include is we need to include parentheses, right? So we never change this subscript that's attached to the back side of the periodic table chart, but I might need 2 of these. So now that makes that +2, and that is -2, and now they are equal. Okay, so that's a tough little problem to put parentheses in. All right, so now let's go to copper 2 nitrate. Copper 2 nitrate, ready? Cu is copper, and then NO3 nitrate. Well, we know nitrate's -1 from the last problem. Well, what is the charge on copper? Well, copper can be a +1 or a +2. Okay, well, what is it? Well, it's +2 because the Roman numeral tells you that it's +2. So +2 -1. So I crisscross them, and I'm going to get CuNO3 with parentheses around it. Okay. Manganese 3 phosphate. All right, so manganese can be +2 +3 +4, right? But it's +3. This Roman numeral tells you that it's +3. So manganese phosphate, PO4, all right? So manganese is +3. Phosphate, I'm going to look on the back side of my periodic table, is -3. Are they equal? Then that is your final answer. Okay, so that's polyatomics. Nothing really changes for what we've been doing. All that changes is the back end a little bit. Okay? So going the other way, from formula to name. So now we're going to go the other way. All right. The one thing that you always have to ask yourself is, can the metal have more than one charge? All right. If it can have more than one charge, it's a multi-charged metal, and you need a Roman numeral. If it can't, you need to have it just write it out. Okay, and then that is kind of what happens with polyatomics. You can have single charged polyatomics, or you can have multi-charged polyatomics. So let's just go to our flow chart and just kind of follow along. All right. So barium, Ba. Can the metal have more than one charge? Well, let's find out. We got to look. Ba. Nope, it's +2 always. Okay. So barium is +2. What that tells me is that now that I have a single charged metal, all right, and this big ugly thing is nitrate. Okay, so it's a single charged metal. You just write it out. You don't have to have a Roman numeral. So I'm going to write it out. Barium, and then this thing is on the backside of the periodic table, nitrate. Alrighty, go ahead, pause the video, see if you can do this one. Okay, so can calcium have more than one charge? That's what you have to ask yourself. That's what my flow chart says. Can it have more than one charge? And the answer is no, it can't. Calcium is always a +2. Okay, calcium is always a +2. So calcium, Ca, all right, it's always +2. And then carbonate, CO3, is on the back side of my periodic table, CO3, and that is -2. All right, so that's kind of how that rolls. Now we just write it out, okay? We just write it all out. Calcium, carbonate. No Roman numeral, no nothing, because calcium is a single charged metal. All right, now this is going to get a little tougher when we get to what we call multi-charged metals. All right, so now, can iron have more than one charge? Well, let's find out. Iron is a +2 or +3. So what that tells me is that we are in the multi-charged section. All right, so now I need a Roman numeral to indicate the charge. Well, how do I know? Well, you use the formula, okay? And the best way to do it is to crisscross up. All right, so iron can be +2 or +3. Okay, well, nitrate is always -1. You could do this. You could say, well, I have 3 of them, so it's -3. Well, therefore, it's got to be -3 +3. Or you could crisscross on up, and then that'll give you your answer. Okay, so iron 3, Roman numeral, nitrate. Cool. Okay, pause the video here, see if you can do this one. Copper Cu. Okay, so can copper, the question is this, can copper have more than one charge? Yes, it can. It can be +1 or it can be +2. Okay, so it can be +1 or it can be +2. Well, what's sulfur? Sulfate. Sulfate on the backside of my periodic table, sulfate is -2. Okay. Well, since this whole thing is -2, which one does copper have to be? Well, it has to be +2 then, because they cancel each other out. If it was 1, there would be a 2 there, okay? But it's not. It's just copper. So we write it out. Copper 2 sulfate. Alrighty. So that's it, okay? That's polyatomic formula writing and name writing, and it's really hard. We're not telling you it's easy. It's hard. It's a challenge, and especially to do it from home here is really, really tough, okay? So what you need to do is just make sure that worksheet's done, turn it in, and tomorrow, guys, we will get really good at this, okay? And then we'll tidy it up before our test. So thanks for listening. Email us with questions, concerns, and you guys rock. Thanks.